2.4, dividing radical expressions. We're doing these notes all in one day, one section, one day. All right, so we've got, the first thing we're going to write is just an important, like, general statement. If we have the nth root of something that's being divided, so there's a quotient in there, it's a fraction, it's the same as dividing, you can break that up into two separate roots. You can make that the nth root of A over the nth root of B. So that's like, I would put it in a box. That's like the big important thing. If you have something divided in a root, you can break it up into two separate roots. So we're going to start with some very simple examples. So in these we're going to simplify by, we're going to take the roots of the numerator and denominator. So the first one is the cube root of 27 1/25ths. So the cube root of 27 over 125. So you're not going to have to write this out every time, but just remember that you can think about this as the cube root of 27 over the cube root of 125. Like, you don't have to know anything about what the fraction 27 1/25ths is. You can just do it as two separate roots. So what's the cube root of 27? Do you guys know that one? 3. And what's the cube root of 125? 5. So there's your answer, 3/5. Let's try another kind of simpler one, and then we'll move into some more difficult ones. So let's try the square root of 25 over y squared. The square root of 25 over y squared. So remember, you can think about this, and you don't have to write this every time, as the square root of 25 over the square root of y squared. So what's the square root of 25? 5. And what's the square root of y squared? Just y. Square and square root cancel out, so it's just 5 over y. So now we're going to try a couple more difficult ones here. So we're going to divide these, and if possible, we're going to simplify them. Or just simplify, I guess. I don't know why I wrote that. I guess I should have wrote just simplify. I'll do them. I'm just letting you guys write it down. So remember, we can break this up into two square roots. So this is the square root of 16x cubed over the square root of y to the 8th. And then we're going to simplify those, because I think we can simplify both the numerator and the denominator with this guy. So when we're looking at, let's just look at the top for now. This is the square root of 16 times the square root of x cubed. What's the square root of 16? 4, and that guy just comes out, right? So there's a 4. Now this is x to the 3, and it's the square root of it. So how many groups of x's get to come out? Just one, yeah, one group of 2, right? Because x, x, x. One group of 2 gets to come out. One x has to stay on the inside. So since there were 3 x's and we're taking the square root, we're looking for pairs of 2. One pair of 2 gets to come out. Here's his representative, and one had to stay inside. And then on the bottom, what's the square root of y to the 8th? Remember, we can think of that as y to the 8 halves, and it's y to the 4. So then we're done. This marker is awful today. I need to try and get new ones. Well, I lost like the little marker points. I guess I could use it just right with my finger. Well, they were like hardly in there and they fell out and I think they vacuumed and then they were gone. Yeah. I'm sure you can buy them, but they'd probably charge you like $20 for a little tiny piece of rubber. Huh? Oh yeah, that's I actually have a hot glue gun right over there. Maybe I'll try that. Well, I'll try it when you guys are doing your homework. Alright, next one is the cube root of 27 y to the 14 over 8x cubed. Personally, when I'm writing these, I start to get annoyed by how messy these things look, and I start writing it like pretty big on my paper. So this is where I kind of was thinking that the fraction things would be helpful. So let's think about this just part by part. So let's first do, what's the cube root of 27? 3. That just comes out, right? 3. And then what I would do to kind of make this easier on myself, you might automatically know how many pairs of y's get to come out, how many stay on the inside. Do you guys like to do it that way, or do you like to do it the fraction way, or how do you like to do it? You like which way? Where you just think about it? So yeah, so you can think about it like, how many 3's fit into 14? 4, right? So y to the 4th gets to come out. And then how many were left? There's 2. So you have the cube root of y squared left because there were 2 y's left. So we asked ourselves, how many 3's went into 14? And the answer was 4. And then that gives us 12 y's accounted for, so 2 of those had to stay on the inside. And then on the bottom, yeah? Okay. Alright, so then on the bottom, what's the cube root of 8? I think it's a whole number. 2. What's the cube root of x cubed? Just x, right? And then I would just check and make sure you can't simplify like the 3 over 2, and you can't, so that's our answer. I know it, like, honestly, you're like, that doesn't even look any better. It looks worse, but oh well. Well, this next one's gonna look prettier when we're done. Alright, so on this one, this is the example where I meant to write divide and simplify. So our first one is the square root of 80 over the square root of 5. No, this one is divide and simplify. So, since both of these square roots kind of stink, like square root of 5, well, we can't even do anything with that. What you can do is you can just divide 80 divided by 5. How many times does 5 go into 80? 16. Okay, so this is really the square root of 16, because we did 80 divided by 5, and that gave us 16. Because we can, it's the opposite works too. We can take 2 square roots in a fraction and put them into 1. So that's the square root of 16, which is 4. That's it. I don't know about that. I don't think you were right though. All right, second one. We've got 5 times the cube root of 32 over the cube root of 2. My notes take up a front and a back, and we are almost done with the front. Everyone's here, but I am recording it. Next year, like if you guys like forgot how to do something, you could go back and look at part of it. So what we can do on this one is, since these are both cube roots, we can divide that into one cube root. Now, this would not work if there was a plus or minus between the 5 and that. Pluses and minuses always screw everything up. But this works. What's 32 divided by 2? 16. So this is 5 times the cube root of 16. And then I think we can simplify that. The cube root of 16 is not 2. The cube root of 8 is 2. Let's try tree method. Let's see. 16 is 2 times 8, which is 2 times 4, which is 2 times 2. Or 4 times 4, and they each break into 2. So either way, you've got 4 2's in the end. One group of 3 gets to come out. This one guy has to stay inside. So on the outside, we've got the 5 already, because the 5's already out there, times that representative that's showing up for this group of 3 2's. And then we have this 1 2 staying on the inside. So yeah, I want you to write 10, but I wanted you to show where I'm getting the 10. I wanted to show you where I'm getting the 10 from. We have 2 more problems before we're done with the front page of notes. All right. Next one. We've got the square root of 72xy over 2 square root 2. So on this one, since it's both square roots and there's no plus or minus messing everything up, we can divide the stuff. So what's 72xy divided by 2? 36xy. So this is the square root of 36xy over this 2 is still here. This 2 is still here. And all this stuff went into one square root. It's right there. Now within that red square, do you guys need to go outside? Because you could just watch the video and do the homework all at home. Okay? This whole table, you're just constantly laughing. Alright, so in this square root, I don't think we can do anything with the x and y because they're not going to have any pairs, but what about the square root of 36? 6. So it's going to be 6 times the square root of xy all over 2. Do you think we should leave that as our answer? What can I do? Yeah, 6 divided by 2 is 3. So this is just 3 square root xy. All right, one more problem and we're halfway done. We've got the 4th root of 18a to the 9th, b to the 5th, that's a 9, all over the 4th root of 3b. So let's go ahead, and since they're both 4th roots, we can divide what's in there. So this is going to end up, it's going to still be a 4th root. And now let's divide. What's 18 divided by 3? 6. And then the a to the 9th is just going to stay there, right? Because there's like no a's to divide it by. So the a to the 9th stays on top. And then what's b to the 5th divided by b, that's a 1, to the 1? B to the 4, because I was going to say minus. We subtract the top minus bottom. B to the 4th. Or dividing bases, we subtract their exponents. So let's see. Are we going to be able to do anything with the 6 and the 4th root? No, because 6 is just 3 and 2, so we can't do anything. So we know that the 6 is going to stay inside the 4th root. What about the a? There's 9 a's. How many groups of 4 are going to come out? 2 groups of 4, right? Because 4 fits into 9 2 whole times. So a to the squared comes out. Sorry, this is like separate right here. And then how many were left in there? Just 1, right? Because when the 2 groups of 4 came out, that was 8 A's. They left one guy behind in there. So they left 1 A in here. And then what's b to the 4th? What's the 4th root of that? b, and he's outside, right? One group of b's got to come outside. So it's a squared b times the fourth root of 6a. That's our answer. So these get complicated. I really want to make sure some of you guys, I'm sorry, but you have horrible handwriting. You need to really make sure I can tell that that 4 is with the fourth root and make sure it does not look like it's out the big number outside of it. Some of you guys write your letters like size 26 font. So if you do that, you just need to be really careful that I can tell what it is. Was that the, okay, now we're on the back. Yay. Oh, rationalizing denominators. Oh my goodness. Okay. So we're about to do something called rationalizing a denominator. So what that means to rationalize the denominator is it means that we're going to get rid of any roots in the denominator. So it's just one of those kind of weird rules, like, you know, we don't like negative exponents, so we move them to the bottom. It's kind of another weird math rule, like, we don't like square roots or any kind of root to be in the denominator. Like, when you get to math classes where you're using this a little more, like in college especially, you don't want any square roots in the denominator. Kind of messes things up. So what we're going to do on these examples is we're going to rationalize the denominator. We'll start with easy ones, and then in 7.5 it gets a lot tougher. So let's see, on A, we've got the square root of 7/3. So this one, it doesn't really look like there's a square root in the denominator, but if there's a square root around a whole fraction, that means there's a square root in the denominator. There's a square root over that 3, because this means the square root of 7 over the square root of 3. So we want to get rid of that square root of 3. We don't like it. Can you guys think of something? What would happen if I did the square root of 3 times the square root of 3? It'd be the square root of 9, which is 3. It would be just a regular number. There'd be no square root anymore, right? So if I could somehow multiply this guy on the bottom by the square root of 3, square root of 3 times the square root of 3 is 9, and that's just 3. But if I do that, it's going to change the value of this fraction. I don't want to do that. I want it to stay the same. Elise? Yes, why would that make it stay the same? Yeah, exactly. Because we're just multiplying it by something over itself which is just 1, right? Like we're not changing the value of this fraction at all. So we're gonna use this over and over and over to rationalize denominators. So this means we've got, what's on top now? What's the square root of 7 times the square root of 3? Square root of 21 over, what do we say square root of 3 times square root of 3 is? 9. Or not, no, square root of 9, which is 3. So when you multiply a square root by the same number in a square root, basically the square roots go away. Because this is basically the square root of 3 squared, right? The square root and square go away. So does that concept make sense? That we can get rid of square roots in the denominator by multiplying by whatever root's in the denominator, we're going to multiply it by on top and bottom. Let's try another one to make sure you guys get this. Is it okay if I already go harder? I'll take that as a yes. Alright, so we're doing the cube root now of 5 over 16. So you're going to have to really think about these. After this one, we have 1, 2, 3 more examples. Okay, so remember, this is the same as the cube root of 5 over the cube root of 16. Now on this one, I can't just multiply the cube root of 16 by another cube root of 16. That doesn't necessarily make it go away. That only worked for a square root. So in this one, think about 16. It's 2 4s, right? Is this how I wanted to do this one? Yeah. It's 2 4s in there. How many more 4s would you need in there to get it so it would kind of come out? Just one more, right? If we had one more, we would have a group of 3 4s. So the way you can think about this is the cube root of 5 over the cube root of 4 squared. We only need one more 4 to get us up to a group of 3. So we're going to multiply on top and bottom by a cube root of 4. So let's multiply this out. The top part is easy. What's the cube root of 5 times the cube root of 4? Cube root of 20, right? I just multiplied 5 times 4. Now on the bottom, I'm taking this in very slow steps. You're not always going to have to write all of this out. We've got 4 squared times another 4. That's 4 to the 3, right? In the cube root. So this is the cube root of 4 to the 3. Because I had 4 squared times one more 4. And then what's the cube root of 4 to the 3? 4. A cube root and a power of 3 cancel each other out because 3 over 3 is just 1. So this is the cube root of 20 over 4. And now we don't have any roots in the denominator. Yay, because we hate roots in the denominator. They're bad. 3 more. Alright, so the next one I'm going to go back to a square root. We're going to do the square root of 4 over 5 square root x. So this one's a little different because there's something on the bottom that's not in a root. So if there's something on the bottom that's not in a root, like it's fine. We don't really care about this 5. He's fine on the bottom. But we don't like the square root of x. So what can we multiply by on top and bottom to get rid of the square root of x, Jeb? Square root of x. So we can multiply by square root of x on top and bottom, because if we just did it on the bottom, that would change the value of that fraction, and we don't want that to happen. We want it to stay the same. So on top here, if I multiply this out, I've got the square root of what? 4x. I just multiply what's in there. Then on the bottom, remember I had this 5 sitting out here, so don't forget the 5. He's going to go right here. And then what's the square root of x times the square root of x? The square root of x squared, which is just x. So when you have something in a square root times the same thing, it just basically the square root goes away. Okay, let's do a tough one. We're going to do, on the numerator, 3b times the cube root of a over the cube root of 25bc to the 5th. And we're trying to rationalize the denominator. So that means we're getting rid of roots in the denominator. We do not like them. Okay, so we don't like this root on the bottom. So the way I would do this is you might want to think about this in terms of what powers we already have. So like the top is fine. It's just 3b cubed root a. I just rewrote the top. On the bottom, let's write these things in here to try to get up to powers of 3, because that will make us go out. So 25, how can we write that as something to a power, Jeb? Yeah, it's 5 squared, right? So it's a 5. It's a power of 5. The b is going to just have to be a b, right? I'll try to color code this. The b is just a b. Can we take any groups of 3 out of that c? How many groups of 3? One group of 3, right? So we've got this. If you want to rewrite it like this, you can think of this as c to the 3 times, why did that change color? Times c squared. So I'm trying to write everything as powers because I'm looking for powers of 3, because I'm looking out to pull out powers of 3 because of this cube root. So let's just keep rewriting this guy. I'm gonna leave the top the same, but we've got to think about what we want to multiply by here. So I need to multiply by something over itself. So just take this in parts. How many more 5s do I need to get a group of 3? I have 2, so I need how many more? One more, right? So I'm gonna multiply by a cube root of 5, because I need one more 5. How many more b's do I need to have a group of 3? Two more, right? This is a b to the 1, so I need 2 more b's. This c's already a group of 3. He's good. How many more c's? One more to get to a group of 3. So one more c. Whoop, that was supposed to be blue. So we need to multiply by that on top and bottom. So we're going to put cube root of 5b squared c on the bottom. Because we're trying to get up to groups of 3. We needed, sorry, yeah, top and bottom. We need one more 5. That's where that 5 came from. We need 2 more b's. That's where that one came from. And we need one more c. That's where that guy came from. Because we're trying to get groups of 3. So I'm going to have to go down to the next line to multiply these. Yeah? Yes, and that's good, right? Because we don't want to change the value of this fraction, so we want to multiply it by 1. So it won't change, but it'll get rid of the root in the denominator. So let's go ahead and multiply this. On the top, the 3b on the outside is going to stay on the outside. And then we're going to have the cube root of, and we're just going to jam all this stuff into this one square root. 5a b squared c. So I just stuffed all that stuff in those roots on the top. I just stuffed it all into one root. Then on the bottom, let's go ahead and write this out, even though you might already know what comes out. We've got a cube root, and let's keep it as powers. What do we have a 5 now? 5 to the power of 3, because 2 plus 1 gives us 5 to the 3. Now what do we have? B to the 3, because we add up those powers. And then we have this c to the 3. I'm going to leave it separate. And then we have another c to the 3, because c to the 2 times another c is c to the 3. So then now let's start thinking about what can come out on the bottom. Okay, so I'm going to rewrite the top the same. Are you listening to this, Clay? Because you just said you didn't understand it. Now you're not even listening. So on the top, we've got 3b times the cube root of 5ab squared c. I just kept the top the same. Didn't change it. Then on the bottom, we've got a group of 3 5s. He gets to come out, right? 5's coming out. This b is coming out, right? Because b to the 3/3 is just a b. This c is coming out. This c is also gets to come out. This is a long problem, I know. All right, now I'm going to do two things at once because I know you're getting sick of writing this over and over. So first of all, is there something I can simplify on the top and bottom that's outside the root? What? 3 and 5 don't simplify. B over B, what's that? 1. So B's cancel out. And then how can I write C times C better? C squared. So here's what I've got left over. 3 times the cube root of 5ab squared c over 5c squared. That was a tough one. That's one of the harder ones. Now we've got one more. Oh my god, really? Hey, you guys are lucky you're going to have time to work on your homework still. Well, if I made this video normally, you guys wouldn't have. It wouldn't have taken so long. Alright, one more example. This one, sometimes in certain situations, depending on what you're doing, you're going to want to rationalize the numerator. So sometimes they're going to tell you rationalize the numerator. That just means get rid of all the roots in the numerator. So what we're going to do is, here's your problem. the cube root of 4a squared over the cube root of 5b. So we're trying to get all the radicals out of the numerator now. Normally it's denominator. Denominators are what we normally rationalize, but sometimes it's good to not have any roots in your numerator depending on what you're doing. So in this one they want us to rationalize the numerator. So I'm going to do similar to what we did last time, and we're going to write the numerator as powers of things. This one's not as tough as the last one. So I'm just going to rewrite this. Denominator is fine. Cube root of 5b. I'm just leaving the denominator the same. And then on top, we've got the cube root of, can you write 4 as something to a power? 2 squared, right? 4 is 2 squared, and a is already a squared. So I'm just rewriting the numerator as powers. So I'm trying to rationalize the numerator. So now let's think about how many more of each of those things I need to get groups of 3. So on the top, I'm multiplying this, not equal to. Multiply by something over itself. How many more 2's do I need to get a group of 3? One more. I've already got 2. I need one more. So I'm going to multiply this by the cube root of 2 to the 1. And how many more a's do I need? One more, right? A to the 1. And I need to multiply by the same thing on top and bottom. Whenever I'm rationalizing, whatever I multiply by, same on top and bottom. I'm going to have to work down because I don't have room to go over anymore. So on top, I've got now the cube root of 2 squared times 2 to the 1. That's 2 to the 3. And a squared times a to the 1. That's a to the 3. Not yet, because we can simplify that. And then on the denominator, I've got the cube root of what? What's 5b times 2a? 10ab. 10ab. So I just multiplied the 5b times the 2a on bottom. Now we're trying to rationalize the numerator. We're trying to get rid of the roots in the numerator. Did it work? What's 2 cubed? What's the cube root of that? 2. And what about the cube root of a cubed? A. He just gets to come out, right? And then on bottom, this just stays. The cube root of 10ab. That's it. How come I can't cross out that a and that a? Good. One of them's in the cube root, so it's not really an a. Can't really cross it out. So then you're good. Okay, so now you guys can have the last 6 minutes to work on your homework. Yay. I won't close it. I'm just going to end.